Hello everyone, this is Grade 6, Module 2, Lesson 15 problem set. The direction state use mental math, estimation, and the division algorithm to evaluate the expressions. So, a lot of work going on here. I won't be solving every one of these. I'll try to provide you with the answer so you can check it. But I'll at least get you started with how you would solve this. So, for number 1, I think the easiest way to go about this is to get 6 4/10 into a whole number using that fraction use that we had before. So I know that the divisor is the tenths, so I want to do a 10 over 10. And that'll help out, and that's going to change this to 1,184 divided by 64. That's the first step, and then you'll divide out. To get 18 5/10 for that. So I'm going to provide you with some strategies, and I'll probably solve out a few of them, but I want to at least get you set up with what's the best approach. I feel like 1, 2, and 3 are going to be solved this way, using just multiplying by 10 over 10 here, 10 tenths, and 100 hundredths there because of the 56 hundredths. I feel like that's the easiest way to do it, unless you can find another way, obviously, using some mental math for it. Once we get into our second row, we can start seeing that mental math piece come in. And I'll bring 4 down. And what we have is 325 divided by 2 5/10. Well, I know that 5/10 is very similar, or is the same as 1/2. So if I multiply that by 2, I know that that's going to get me 5, because I'm doubling it. So if I double the bottom, I have to double the top, because I have to have a fraction that's equivalent to 1. So 325 times 2 is 650. Now I can do 650 divided by 5. And I'm going to get the same answer as if I had done, turn this one into a whole number, which would have been 25, and this would have been 3,250. It's still going to get you the same answer, but now I'm using a 1-digit divisor instead of a 2. Oops. Well, 3 for 15. And then I got a 0 there, so that's 0. So 130. And that was using mental math and then the algorithm afterwards. Same thing for this one. I have 196 and 3 5/10. I know that with 5/10, if I multiply it by 2, I'm going to get a whole. So 3.5 times 2 will get me 7. And I have to do a 2 over 2. My numerator and denominator have to be the same for what I'm multiplying by to make it 1. So 196 times 2 will get me 392. And now I can easily divide that out. And I'll do that right over here. And you're seeing that this one is easier to do when I go to a 1-digit divisor, as opposed to doing 3 5/10 and then making that a whole number, which would be 35. And then I would have to do 1,960. So I'm still able to, because if I made 3 5/10 into a whole number by multiplying by 10, it'd be a 10 over 10, which is still one whole. 2 over 2 is still one whole. So it's still the same math problem, and I'm still going to get the same answer, but I'm just making it a little bit easier on myself. And there's a way to do it with 1, 2, and 3, but it's a little challenging to do that piece. So I might even consider with 3 estimating, and then giving it a shot. But for 6, we can do the same thing with the 5/10. I would still multiply by 2 over 2, and then I would divide out that. And I want to jump down a little bit so we can look at some that maybe don't play out perfectly, like 8. If we made 5 and 25 hundredths into a whole number, we're going to get 525. That's a very big number that we have to work with. So what I would do is I see the 25 hundredths. If I multiply 25 hundredths times 4, I get 1 whole. So I'm going to multiply that whole thing. And again, I'll show you down below. I'll slide down and I'll do 8 down here. I know I'm jumping around more than I normally do, but this lesson kind of tends to, I want to be able to give you a strategy to use for each of the different types of problems that you're seeing. I'm looking primarily at the decimal. How do I get that to 1 whole? Well, if I multiply that by 4, it's 1 whole. So I would do 5 and 25 hundredths times 4. So 5 times 4, this big 5 times 4, the 5 whole is 20. And then we have 4 times a quarter, which will get us 1, so that's going to be 21. So 21 is a little more manageable than 525. And then I just have to do the top part by 4. And that might require me to do some multiplication, but I'd rather multiply first and then divide by a smaller number than to divide by 525. So you might end up having to do a little bit more work initially, but it will save you time in the end. And right now I'm just multiplying this out. And I know I was doing hundredths times 1, so hundredths. I have to make sure I have something in the hundredths. And that actually came out even, so 157, or 1,575 divided by 21. So now you can divide that out rather than dividing something by 525. Let's take a look at a couple more. So when we have a 75 hundredths in our decimal place, we just worked with that actually down below, but I'll do it off to the side. So I'm going to do 11 over here, and I have 92 divided by 5 and 75 hundredths. Now, how do I get 75 hundredths to a whole number? Well, I saw it down below. If I do it by 4, that will work. And I'll show you what I mean. And I actually get 15. So 15 when I do this. And then I have to multiply the top by 4. And again, why am I doing this? I'd rather divide by 15 than 575, because that's what that's going to be if I turn that decimal into a whole number. So I'm trying to make this more manageable on myself. This other one, when I multiply that, I'll get 368. And I would rather do 368 divided by 15 than to do 9,200 divided by 575. Just more manageable numbers. So to do the extra step to multiply first will actually create a smaller division problem in terms of calculation for me. So that's how we can do that in terms of the ones for 75 or 75 hundredths, which is what I wanted to show. The last one we'll look at up above is 15. So I'll pull 15 off to the side. And I want to do 305 and then 12 and 2/10. I know 5 or 2/10, if I multiply that by 5, I'm going to get it to 1 whole. And that'll give me 61. And again, I can show that down below. This is my mental math piece going in. So 61, and then I have to multiply the top by that. And I see I'll end up with 1,525. And then I can divide that out rather than doing 3,050 divided by 122, because that's what it would be if I just multiplied by 10 over 10. So what I'm doing is just taking a different fraction rather than multiplying by tenths or hundredths or thousandths for the place value of the divisor. I'm just finding a way to get it to a whole number a different way using some mental math. And that's really going to help out for it. So down at the very bottom, we have 16, 17, 18, 19, and 20. What they're looking for is the decimal places. Place the decimal point in the correct place to make the number sentence true. Some of them they have already given it to you, and you just have to decide where that decimal place is going. So what you want to do is solve out for this first one, for 16. The first thing we need to do is get that divisor to a whole. And we'd have to multiply by 10 here and 10 here. So actually it'd be 833 and 75 hundredths divided by 23. And I know that I have hundredths right there. So it should be back into the hundredths. So it should go in between the 6 and the 2. Now, the next one, they have the decimal given here. They have the decimal given there. We're looking for the decimal in terms of this. So a way to look at it is we really got to think. Our answer is right around 3, I'm going to say. So this whole number has to be able to go into this 3 times. And I know 5,245 is much larger than 183, so that's not going to work. If I put the decimal point right there, it's still not going to work because 524 is larger than 183. But if I move it over one more and put it as 52 and 45 hundredths, 52 times 3 is going to get me something close to 183. So that's got to be where it is. Because if I put it over between the 5 and the 2, 5 can go into 183 more than 3 times, because 3 times 5 is 15. So that's kind of really tying this whole thing together. And we'll take a look at 18 to see it, because again, we got to put the decimal into this. We know our answer is 3, so I have 9 as my whole number. So 9 can't go into 3, but it can go into 32. And it can go into 32 3 times. And that's what I need. So that means the decimal point goes right between the 2 and the 6. Because if I do 9 goes into 32 3 times, everything after that's going to be the decimal point, which would be the 45 hundredths. Let's take a look at 19. And again, I have to try to get 6. Well, I know that 725 is much larger than 449, so that's not going to work because my answer would actually be a decimal, not have a whole number. But if I put it right there between the 2 and the 5 and make it 72 and 5 tenths, that's going to get me close to 6. Because 70 times 6 is 420, and that's very close to 449. So it's 72 and 5 tenths. If I put it all the way out between the 7 and the 2, that's 7 and 25 hundredths. 7 can go into 449 about 60 times. And we're not looking for 60, we're looking for just 6. So over to the last one, 20. I need to get an answer of about 52. I have 85. So what I could do is just say it's about 50. So if I did 85 times 50, so I'm looking for something around 4,250. So I could see 4,000, 4, 6, I would put it right there. So 4,466 and 4,200s, because when I multiplied those two together, I rounded. That's another strategy to use. I just took 85 and rounded 52 to 50 because it's very close to a multiple of 10, multiplied them and got this, so I got to make something in the thousands. Meaning, I counted over 4 places and added my decimal point. And that would work for any of these ones where you're looking for the decimal on this back end. So, hope this helps. Thanks for watching, and good luck on the rest of your problem set.